A statistician recorded the pregnancy rate per 1,000 U.S. women aged 15 to 19. Oh boy, I don't like this at all. From 1990 to 2002, a linear regression was used to develop a linear model for the pregnancy rate over time. The figure shows a graph of the residuals of the linear regression. Which of the following statements about the linear model is true? Now, this is a residual plot. And whenever you have a residual plot, the residual plot is basically the result of you coming up with a line of best fit and having dots above and dots below and dots above again. Now, this guy is just a very, very, very terrible looking rough sketch of what we have over here. Now, if we saw a bunch of dots on a scatter plot that looked kind of like this, and we drew a line in between them, most people would look at that and be like, yeah, I'm not super happy with the line, but I guess that line does fit the data. Well, that's what we're doing here. A residual plot fits the data if there's no pattern whatsoever to my dots. You have a bunch of dots up here, you have a bunch of dots down there. I don't see a pattern at all. So this linear model is appropriate because it fits the data. So the linear model is appropriate, the linear model is appropriate, C and D are not going to be the option. Now, why is the linear model appropriate? Because the residual plot shows a clear pattern? No, it's because the residual plot does not show a pattern. Okay, now what they mean by shows a clear pattern is maybe you have a residual plot and the dots go up and down like that. That would be a clear pattern. With this guy, we just have dots scattered above and below, and there's really nothing that's there to it. It's just that line kind of goes in between, and therefore the residual plot seems to work and the linear model is appropriate. Fun stuff.